If one was to identify one of the most important challenges facing medical science in the past 30 or more years, it would be the endeavour to develop a vaccine to prevent HIV/AIDS. At the very heart of this endeavour across the world has been Professor Glenda Gray, taking on a particularly pressing challenge in South Africa, where an estimated 6.5 million people live with HIV. Professor Gray is a leader of the HIV Vaccine Trials Network, a global network striving to create a preventive HIV vaccine headquartered at the Fred Hutchinson Research Center in Seattle. Also a member of the World Health Organization's AIDS Vaccine Advisory Committee. She and her team are leading the world's largest HIV vaccine trials, involving 5,400 participants across 15 sites, backed by funding to the amount of almost 2 billion rand. The research aims to discover more about how the immune system can develop ways to counter HIV, using a strategy that primes the immune system with a viral vector containing HIV synthetic antigens and causes the immune system to develop antibodies that will bring protection against HIV. Behind her determination to find a vaccine, there is optimism. I want to be part of that team that finds an HIV vaccine, she says, and I believe we will find it. The results of the trials are due to be released later next year. Success could lead to the development of the first licensed vaccine and, no doubt, international acclaim. Her commitment to medicine has been lifelong, wanting to be a doctor from the age of 6. Realization of this ambition was not going to be easy, growing up in a working-class neighbourhood in Boksburg. One of 6 children, she was blessed with supportive parents who enabled her to go to university. So there followed years of study at the Wits Medical School, years that were for her a golden age, being instructed by renowned scientists and inspirational teachers. Years, too, when she was drawn into anti-apartheid activism, joining a campaign to desegregate hospitals, treating people injured in anti-government protests, documenting brutalities perpetrated against detainees, and beginning to be involved in the escalating HIV/AIDS crisis. In the late 1980s, working in townships with healthcare workers in the field of HIV. Following qualification as a paediatrician in 1993, the full horror of the AIDS crisis became evident to her. Stricken at the sight of babies and children dying while working at Soweto's Chris Hani Baragwanath Hospital, where every 3rd baby was born HIV positive. The images of dying infants forever imprinted in her memory. From this time, 25 years or so ago, there developed her determination to fight the virus through research. So began her research into mother-to-child transmission. In 1996, co-founding the Perinatal Research Unit at Chris Hani Hospital. In this endeavour, there were obstacles along the way. During the 1990s, Glenda advised the ANC on HIV and helped draft a national AIDS plan. But then came the AIDS denialism associated with the Mbeki presidency, a major setback for researchers and activists. Gray herself getting into a screaming match with the Minister of Health, who was recommending beetroot and garlic as cures for AIDS. When the government refused to supply the necessary antiretroviral drugs in hospitals, Glenda arranged for colleagues in the US to ship them to her. And in 2001, she was among a group who founded the Treatment Action Campaign, which was soon filing a lawsuit demanding the provision of proper treatment for HIV-positive pregnant women. A campaign boosted by the support that Glenda and others received from former President Mandela. Currently a research professor at Wits, among her many positions, Glenda Gray is an A-rated scientist with over 250 articles and papers to her name. In 2013, she became the Director of AIDS Research at the South African Medical Research Council, and the following year was named as President of the Council, the first woman to head South Africa's premier medical research organisation. In this position, her aim has been to broaden her mission beyond HIV to tackle the other major health issues in the country, such as maternal death, diabetes, cancer, and heart disease. She believes that anyone can be a scientist. Not so sure about that, speaking for myself. Research, she says, has kept her enchanted. At the same time, the HIV/AIDS epidemic has had a profound personal effect on her life. It has in some ways enriched me, she says, and in some ways embattled my life. She pays tribute to the team of researchers who have worked alongside her, and for her there are many other heroes. The children who struggle with their illness, those thrown out of their homes or even beaten to death for declaring their HIV status, the nurses, the doctors, the families, those who fought against AIDS denialism. The true heroes, she says, are the people who faced this adversity, stood up, and were prepared to be counted. And mostly, they were just citizens. Professor Gray is humble enough to recognise herself as just work in progress. But such has been the progress already that numerous awards have been bestowed upon her. To mention a few, the Femina Woman of the 90s Award. In 2002, the Nelson Mandela Health and Human Rights Award. The Hero of Medicine Award from the International Association of Physicians in AIDS Care in 2003. The Order of Mapungubwe in silver in 2013. And 2 years ago, named as the only South African in Time magazine's list of the 100 most influential people of the year. Today, Rhodes University is proud to honour a world-renowned scientist, blessed with enormous energy, a deeply caring approach to medical practice, and a fundamental commitment to human well-being. A pioneer in the quest for an HIV vaccine, recognised globally as a leader in HIV prevention research, a medical practitioner who has made major contributions to improving the lives of marginalised, afflicted South Africans. Mr. Chancellor, I have the honour to request you to confer on Glenda Gray the degree of Doctor of Laws, honoris causa.
Thank you very much. The Chancellor, Dr. Justice Lex, I'm very nervous now, Justice Lex Mpati, the Vice-Chancellor, Dr. Sive Mabizela, the Chairperson and members of the Rhodes University Council, Deputy Vice-Chancellor, Dr. Peter Clayton, Deputy Vice-Chancellor, Dr. Chrissy Bowie, the Registrar, Dr. Moodley, the Public Orator, Distinguished Professor Paul Malem, Deans, academics, support staff and students, distinguished ladies and gentlemen, and not at least the new graduates and their families and guardians who are yet to celebrate their graduation, and of course my family, Diane and Albert. So congratulations are in order for the new graduates, your families and friends who have supported you to achieve this major milestone, and it is truly a major milestone. It's wonderful to be here and feel the energy of Rhodes University at the time of graduation. I was out last night and we saw all the young graduates meeting their friends and being excited. They were very excited, but I wasn't sure if they were excited about graduating or about the fact that Madrid beat Manchester United, or maybe both. So I was lucky enough to peruse the history of Rhodes University by the book that Professor Paul Malem has written. And this institution, this university, has a lot to be proud of, and everything from nanotechnology to pharmacy to commerce and to performing arts. It's truly, and I agree, it's truly a jewel of South Africa. So I'm very honored to be here. This honorary doctorate that was bestowed on me today at this graduation ceremony for law, pharmacy and commerce is truly a wonderful gesture from Rhodes University. And I'm deeply honored, and I thank you sincerely for this tribute. So I just want to go, why am I here in the middle of a law graduation? And I wanted to say that there's a natural history and a natural synergy between law and medicine. So getting this honorary doctorate today at this graduation is doubly special, as the law has played an integral part in asserting the right to health in our country. This has been emphasized by the role that law played in forcing the government to provide antiretrovirals to pregnant HIV-infected women to prevent them from transmitting HIV to their babies. The first major legal achievement was through the constitutional court case battle, that famous one that the Treatment Action Campaign brought against the then Minister of Health, Dr. Mantushabalala Masimang, in 2002, the outcome of which was a clear instruction to roll out these antiretroviral therapy. And this rollout eventually led to the control and virtual eradication of pediatric HIV in South Africa. So that's just how wonderful law is and what it can achieve. In addition, through international legal agreements and advocacy, antiretrovirals became affordable during the 2000s, and this consolidated the national rollout of antiretrovirals that has saved the lives of so many people in South Africa. So you can see quickly how medical evidence can be used in legal battles to achieve success in the courts of law, and how medical science has been part of this. So medical science literally saves lives, and this has especially been evident in the field of HIV. So today I will briefly sketch my path in science from a clinical researcher in the field of mother-child to child transmission of HIV. I'm not going to do a good job like Paul Malem did, but I'll be much shorter than that. So as a clinical researcher in the field of mother-to-child transmission of HIV, to my journey to join the endeavor to find an HIV vaccine. So as you've heard, my life as a scientist began when I was a young pediatrician at the Chris Hani Baragwanath Hospital in Soweto on the outskirts of Johannesburg. I was confronted by the HIV epidemic in the wards of my hospital in infants and children who were infected at the time of childbirth or through breastfeeding. I was propelled into medical science by necessity and with an obsession to curb the carnage I was seeing in my hospital. As a young doctor in 1993, HIV became the epidemic of my time. And HIV has consumed the energy of the world in both the 20th and 21st century. It has exposed our medical deficiencies quite greatly, and also the global social inequalities. It has formulated careers and institutions, and the weapons created to fight HIV have been novel, like the Global Fund, UNAIDS, the famous Treatment Action Campaign, the Treatment Action Group, and PEPFAR. And all of these wonderful weapons have really gone to scale to deliver life-saving antiretroviral therapy to people at a global level. As mentioned before, the epidemic also affected me personally, as has been the case for many of my colleagues. And it pulled me from a clinician, a pediatrician, into a scientist. For me, my experience with HIV has mostly revolved around young children and their mothers. And as you've heard before, we were enriched by the epidemic, but also embattled. So it's sometimes difficult to talk about HIV in the early years in South Africa, especially in the late 90s and early 2000s. As we battled the disease in the wards of the hospitals, there was a different battle that was being played out in the public domain, and that was one of AIDS denialism. AIDS denialism had a serious and significant impact on public health policy in South Africa, and this was under the presidency of Thabo Mbeki. Mbeki criticized the scientific consensus that HIV caused AIDS, beginning shortly after his election to the presidency. As a president, Mbeki continued to express sympathy for HIV/AIDS denialism and instituted policies that denied antiretroviral drugs to AIDS patients. The Mbeki government even withdrew support from clinics that started using AZT to prevent mother-to-child transmission of HIV, as well as preventing women who were raped from receiving post-exposure prophylaxis. He also restricted the use of a pharmaceutical company's donated supply of nevirapine, a drug that helped keep newborns free from contracting HIV. Instead of providing these drugs, which he described as poison, shortly after he was elected to the presidency, he appointed Dr. Mantu Shabalala Msimang as the country's health minister, who promoted the use of unproven herbal remedies such as garlic, beetroot, and lemon juice to treat AIDS. These remedies and these policies have been blamed for the preventable deaths of about 350,000 people in South Africa. So if you take this over a period of 10 years, it's about 35,000 people a year, which is about 100 a day or 4 an hour. All of these could have been prevented. So what was the response of a lot of us who were doctors at that time? And so a lot of us became researchers. And together with my colleague James McIntyre, who was an obstetrician, we started an HIV clinic for pregnant women and their children, which led to the establishment of the Perinatal HIV Research Unit that has since been responsible for groundbreaking research that has impacted on the outcome of HIV-infected infants, children, and adults the world over. So I cut my teeth on research that looked at interventions to prevent mother-to-child transmission and was fortunate enough to be part of a team that led the first rollout of PMTCT interventions in Soweto. While I was busy with this work, the South African Medical Research Council approached me to join a team of South African scientists to work on a South African-derived HIV vaccine program. As a clinician, I would design the studies from preclinical work in animals to clinical trials in both South Africa and the US. In this program, we successfully completed 2 clinical trials. This initial work catapulted me to join international collaborations working in HIV, largely funded by the US NIH. So I believe only a vaccine can end or at least control the HIV epidemic. And I'll repeat that. Only a vaccine can end or at least control the HIV epidemic. Since HIV was first discovered in 1983, which is about 36 years ago, this quest has proven to be far more difficult than we ever imagined. Solving the science to find an HIV vaccine is akin to landing a man on the moon. I was 5 years old in 1969 when the first man landed on the moon. I can remember sitting there with my family listening to the radio on the night that this happened. A few days later, my father drove us to the Johannesburg City Hall, where we saw the grainy silver pictures of Neil Armstrong descending down from the ladder. John F. Kennedy said that they chose to go to the moon not because it was easy, but because it was hard. Similarly, I have seen how hard it has been to crack making an HIV vaccine, and for that reason, I've chosen to commit myself to finding an HIV vaccine because it is so hard and success is elusive. Like landing on the moon, the ideas that made the Apollo 11 initiative successful permeate to the HIV vaccine initiative. One, the beckoning of the unknown frontier or territory, the moon HIV vaccine, the urgency and the plausibility of finding an HIV vaccine, the cumulative strategy that we saw for what it took to take a man on the moon, and then, of course, what's very important, collaboration. It took about 400,000 people to put the man on the moon. So why don't we have an HIV vaccine? It takes a long time to understand pathogens and how to protect against them. It took 105 years after the discovery of typhoid to develop a vaccine for typhoid. For whooping cough, it took 89 years. For polio, 47 years. And for measles, 42 years. HIV also has enormous genetic diversity. It has an extraordinary ability to replicate unrelentingly despite everything our immune system throws at it. And this makes our job incredibly hard. In fact, we don't currently know what constitutes an appropriate immune response to HIV, which makes this quest all the more difficult. We have many hurdles to jump over in trying to find an HIV vaccine, so I'm just going to name 6 of them. Firstly, we don't have any truly useful small animal or monkey model for studying infection, and the vaccines we test in monkeys have to be adapted and therefore don't correlate well with human studies. Secondly, we do not know with certainty which immune response will provide protection, and this is a major problem. Thirdly, we have never before attempted to develop a vaccine against a retrovirus like HIV. Retroviruses, by integrating into genomes such as ours, are able to hide completely from immune surveillance. This means that any vaccine has a small window of opportunity in which to prevent infection and would have to be extremely effective, repelling all attempts by HIV to attach to and infect host cells. Fourth, the pace of HIV replication in our bodies is such that we have about 24 hours after the first CD4 T cell is infected by HIV in which to destroy enough infected cells to control viral replication. Fifthly, a large part of the HIV's genome is devoted to the production of viral proteins that defeat our natural immune responses. Thus, despite this initial burst of HIV viral replication, the immune system fails to see the cells that are producing it. And finally, HIV has evolved a way of tricking the immune system into mounting the strongest and speediest response to the parts of HIV that change rapidly. And so our immune system is always one step behind the HIV virus. So today in South Africa, we are approaching the virus in 3 different ways, 3 different distinct ways, in the form of 3 HIV vaccine trials, of which you've heard about one of them. 2 approaches use the active vaccination aimed at different parts of the immune response to see whether we can induce enough of the immune system to protect against HIV. The third approach that we are using is to use an infusion or an injection of potent neutralizing antibodies to see if this can protect against HIV. These studies are taking place in more than 30 sites in Southern Africa, from Mthatha to Blantyre, from Maputo to Masiphumelela, from Rustenburg to eThekwini, involving more than 400 research staff and now over 10,000 volunteers. What a commitment to science. So in conclusion, I do believe that we are on the brink of discovering what it takes to protect people against HIV. We may be lucky with one of our 3 approaches, but we also may be well sent back to the drawing board if we're not lucky. My colleagues and I are determined to end our careers the same way we started them, without HIV. We want to relegate HIV to our history. But for this, we need you young graduates in this room to help us, to take the baton, to run with us, after us, to find solutions in places we have not discovered yet. You have been equipped by your university to achieve great things, and I'm going to say that again. You have been equipped by your university to achieve great things. And hopefully you will be inspired to tackle deadly diseases like HIV in a transdisciplinary manner in which Rhodes has equipped you to do. And may you then achieve what I can only dream about. Congratulations, you graduates. Thank you very much.